Imagine someone hands you a page where every word is squished together with no spaces, no gaps, nothing. Just one endless ribbon of letters running off the edge. Your eyes have no idea where one word stops and the next begins. So how does a computer ever read code that looks exactly like this? To a computer, code is just that ribbon, a stream of single characters. The very first helper to read it is a little robot called a lexer. Its only job is to slide along the ribbon and snip it into meaningful pieces. This snipping is called lexical analysis. So the robot starts with raw characters. But a lone letter or symbol means almost nothing. An I, an F, a space, a bracket. Grouped together, though, IF suddenly becomes a command. The robot's whole talent is spotting which clumps of characters belong together and which are just noise. Now that clumps form words, each finished clump gets a name, a token. A token is the smallest unit the rest of the compiler cares about. A number, a name, a symbol, a keyword. Think of tokens as the labeled Lego bricks the robot stamps out, one clean brick at a time. So take a real line, x equals 5 plus 2. The robot reads left to right and the line stops being text. It becomes 5 bricks, a name x, an equals sign, a number 5, a plus, a number 2. Same characters now sorted into pieces. But how does it decide where each brick ends? How does it decide? The robot only ever looks at a single character, then peeks at the next. While the characters keep matching, like digits in 5 then 2, it keeps building the same brick. The moment a different kind appears, like a space or a plus, it knows the current brick is done. Inside, the robot runs a tiny decision machine. It sits in a state like reading a number, and each new character either keeps it there or kicks it into a new state. Letters lead to a name state, digits to a number state. These states are how it never confuses a 5 with an X. Once a name brick is finished, the robot checks it against a short list of reserved words like if, while, and return. If it matches, the brick is tagged a keyword. If not, it's just an identifier, a name you chose. This lookup is how if becomes a command, but ifx stays a variable. Remember those spaces. Most of them are simply tossed out. The robot uses whitespace to know one brick has ended, then drops it. The gaps never become tokens. Comments get swept away too, so the noisy ribbon gets quietly cleaned, leaving only the bricks that actually carry meaning. But what if a character fits nowhere? A stray at sign or hash the language never allows. The robot stops and raises a flag, an unexpected token. Catching junk this early, before any real work happens, is a gift. It means errors are found at the very front door instead of deep inside the program. So after the whole ribbon is read, the robot has produced something beautiful. A tidy stream of tokens in order, each labeled with its type and value. No spaces, no comments, no guessing, just clean bricks lined up on a conveyor belt, ready to be handed to whoever needs them next. Why bother making this stream so neat? Because the next helper, the parser, builds the grammar of the program, and it would drown in raw characters. By handing it ready-made bricks, the lexer lets the parser focus on how words fit together, not on where words begin. Teamwork through a clean handoff. And you've actually watched this happen. When your editor paints keywords blue and numbers green, that's a lexer tokenizing as you type. Search bars, math apps, even spreadsheets splitting a formula all lean on the same trick. Chop the text into meaningful pieces first, then understand them. So this humble first step does a lot. It turns chaos into order, throws away noise, catches mistakes early, and gives every later stage a clean foundation. Skip it, and a compiler would have to fight raw text forever. Get it right, and everything built on top becomes simpler. Remember, code is just a ribbon of characters, and the lexer is the robot that reads it one letter at a time. It snips that ribbon into labeled tokens, throws away spaces, flags strange symbols, and hands a clean stream to the parser. That snipping is lexical analysis, the quiet first step of every program.